Hello guys, how are you? How are you doing? Hi, ACCA students. I hope you're doing fine. Okay, I'm Jerry, and in this video, I'm going to just redo some of the examples which we did in the previous video. This time around, I'm going to use uh, much of the tables manually, which I had presented in paragraph form. Okay, the information which I had presented in paragraph form is now going to be tabulated this time around. Okay, I'm going to look at, I think, two examples in our notes. All right, so you discover that we have re-edited some parts of the notes, right? We removed some of the information, which, you would find the notes blank this time around. Why? Because we have removed the first information. We want you to watch this video to see the steps in a tabular form. All right. The methodologies which we used in the previous is still relevant. Okay. If you like that presentation or that way of presenting things, that is going to be fine with you. However, for the purpose of those who are attempting the ACCA performance management, you discover that this particular video is going to be useful in its tabular, owing to its largely use of tables. Why? Because you're going to face spreadsheets in your examination. So it is wiser to to be used or to be exposed to tables for now. All right. Remember, I promised to do a long question, in which I'll be using Excel as well. So, in this presentation, we'll be looking at two variances, if not three, right? The material mix variance as well as the yield variance. All right. So, there is this example, ladies and gentlemen. You know it. You have seen it, isn't it? Good. So, in this example, we are given information which has been pre-populated by the examiner from a very long question, which was wordy, rambling, going up the mountains, downwards, down the valley, all those things. But we have selected the major points or all the information necessary for you to do the computations for the material mix and yield variances. Okay, so for you to attempt a question like this, you need to have the formulas which are required for you to do the computation. All right, you're not going to pass from guessing or through guessing. You need to have the formulas at the back of your head. So, for example, the material mix, we now know material mix variance is equal to the actual quantity minus actual quantity at standard mix, or multiplied by the standard cost or standard price. Okay, we now know this, isn't it? That's fantastic. And we also know that the material yield variance is given by the actual quantities at standard mix minus the standard quantity, right? Multiplied by the standard cost or standard price. Having these formulas ready, okay, ready with you is going to solve your problem. All right, it's going to solve your problem. You're not going to struggle. You just have to slot in the appropriate figures and you move on with your life. All right, but I want to point out certain things before we do the computations, because this has actually given me sleepless nights that I didn't mention these things earlier on. Okay, the reason why we have only put actual quantity there the actual weighting, the real weighting should be actual quantity at actual mix. All right. So we have shortened it to just actual quantity. All right. Because it's actual quantities. All right. Of inputs at actual mix. So by the end of the day, we simply shortened it to AQ. All right. Good. Then, if we come to this one has been elaborated so that you will be able to separate that the actual quantity at actual mix is different from the actual quantity at standard mix or in standard mix. All right. So that's the point I wanted to point out there. Or I wanted to review. Similarly here, all right. For this SQ, the SQ, the standard quantity, is actually standard quantity, okay, at standard mix. Standard quantity at standard mix. You will see how useful this particular information is when we do the computations, because sometimes you will be confused to say, oh man, so what SQ are we looking at and what? All right. This is also important. This point is important in our math formula, because remember we say that the the both the MV, okay, the MMV, the material mix plus the material yield give us the MUV. Okay, they lead to the material usage variance, right? But if you look at the material usage variance, it will say this is actual quantity minus standard quantity, right? That's a close bracket multiplied by standard cost. Okay? Usually the actual quantity is not going to be the problem. Okay? Because that we say that's the actual quantity at actual mix, all right? But the standard quantity, if you don't tell your mind that it is the standard quantity at standard mix, you are going to be confused, because normally the examiner is not going to give you the standard quantities. So you need to tell yourself that where the formula is related to more than one product, the standard quantity is the quantity or the budgeted quantity at the standard mix. Are we together, ladies and gentlemen? All right? Good. Now, with that background, I think we should then do the computations. I'm sorry to waste much of your time in my videos, because you guys just want where the action is, all right? You just want to see where, that juncture or that point of the video where the computations will be taking place. That's a good expectation. Economically, okay? Um, but we need to get as much information as possible. Okay, so we are going straight away to the computation of the material mix variance. All right, for now, let us skip this MUV on the screen there, right, and do the materials mix variance. Now, I want to, do the computations while it's looking at the question. So let me just restructure my screen for now. Okay, right. And we need okay. I'm glad I did not consume much of your time, right? Um, okay, do I have the pen? Yes, the pen is there. All right, can I make my board a little bit tidier? Yes, I can do that with easy. That's fantastic. Okay, now we know the formula as I have listed it on the board. Let's start with the material mix variance. Okay, now we know that material mix variance is equal to the actual quantity at actual mix, right? Minus actual quantity at standard mix multiplied by the standard cost per unit. That's what we know so far. However, we are given two products. All right. So it is essential to calculate the separate variance for each product. So we come here and have our table, right? We start with the material. So even if it's in Excel, just have to have a column for materials, right? A column for the variables in your formula. The first variable is the AQ, okay? You underline, then actual quantity at standard mix. You underline, then the other variable is the standard cost per unit. You underline, and then you get your variance. Sorry, okay, saying that you're now going out of bounds. Okay, that's the variance. Now, we underline our table is okay. In the examination on Excel, no need to do these underlinings and so forth, but you can as well format it if you still have the time, because under exam pressure, it's not going to be very, very easy for you to do so. Okay, now we need to move on. Can I get another color, please? I'm sorry, but I think it's very, 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 very necessary. Okay. Okay. This one. I hope it's readable or it's visible. It's clear. All right. So we have got material A, material B. Now, what were the actual quantities from the question? All right, the actual quantities of materials used are given here. Okay, those were the actual materials used. So for material A, we've got 130, B 80. So we just slot in the figures 130, 80. These are kgs, okay, these are kgs. Then we move on to the actual quantities. Actual quantities at standard mix. Okay, the examiner has done that work for us, right? This time, you just have to, um, you need to add, all right? You add the materials. Actually, in the examination, it's very rare to see the examiner giving you the totals, okay, the total information. They just assume that you know that you need to total. Remember, these variance aspects, we did them at management accounting level, all right? So if you add 130 and 80, you are going to get total inputs which were used of 210 kgs. All right. So when you do your computations, Okay, so I was shifting my face, Okay, now you also have to tell yourself that the total of the actual quantities at standard mix column should actually be the same as the total of the actual quantities at actual mix. All right. Um, but then what you need to do now is to flex the actual quantities in relation to the budget. Okay, in that way, we are saying we need to ensure the budget fits the actual performance. All right. Let me just say the actual performance should actually meet to the dictates of the relevant budget. All right, so we are flexing the actual. We are flexing the actual to come up with the flexed budget. Okay, so we are flexing each item. This one has to be flexed. This one has to be flexed. But we are flexing with what? We are flexing with the ratio, the original ratio, all right, or the original mix. Remember, it's actual quantities at standard mix. All right, so the standard mix was 400 items where we have got 60 kgs, all right, of A and 40 kgs of B. Okay, all right, so our ratio for 100 units, 100 units, the 100 units wanted 60 of A and 40 of B. So we are going to use that ratio in the computation of the actual quantities at standard mix. So we know, this is what we know. We know that for material A, okay, for material A, to produce 100, we need 60 kgs, all right? To produce 100 units, all right, we need 60 kgs of the 100 inputs, 100 kgs input. Remember, the input output ratio here was 1:1. Okay, we needed 100 kgs for 100 units, as you can see. So it becomes 1:1. 100 kgs of input for 100 units. So in terms of units, we need 100 kgs in total. However, for material A, we need 60. So 60 over 100. 60 kgs over 100 kgs of inputs multiplied by the amount to be flexed. And this time it's 210. So what is the amount we need? Okay, so we would need 126 kgs, 126 kgs to produce 210. Yes, we would need 126 kgs to produce 210 units from the ratio. Okay, from the standard ratio. Remember, we are saying 1 kg produces 1 unit. Okay, why? Because when we budgeted, we were saying 100 kgs, we're aiming to produce 100 units. So basically, if we are looking at this, the actual quantities of 210 kgs, we should be looking at 210 units. Okay, so you can see that the actual units of production, okay, you see that they were 200 units. Okay, the actual quantities produced or actual units produced. All right, this is not necessary for this variance computation, but it's essential for the yield. All right, we are simply saying actual quantities produced were 210 when we were expecting 210 units based on the standard ratio, but the actual quantities produced were 200 units. So there is an adverse variance in terms of production. Okay, in terms of the actual production which was sustained, we are having an adverse variance. But that doesn't mean that the material mix variance is going to be adverse. All right? Please get this right. Okay? The mix variance speaks largely of the usage of materials in terms of their mix. But when it comes to the yield, we are looking at the efficiency in the use of the materials. Were we efficient? All right. And then, because we'll be looking at the yield or the product or the quantities of products produced from those few raw materials which we had. Okay. So, that explanation, I found it very, very, very necessary as we do our computations. I'm sorry to eat your time in that aspect or in that regard. Now, let's proceed, ladies and gentlemen. I'm sorry. Please forgive your tutor. Now, we need to then look at the other issue. Okay, the other issue here. Now, we then have to compute the standard cost section. It is better to finish one product in the computation because when time runs out, the examiner might be able to give you some half mark for that variance, and that half mark might turn your 49.5% into a 50. So finish the line. All right. So the standard cost per unit, for material A was $2. So we slot in our $2 there. All right. And we get the variance. What is the variance? The variance now, or let me just say, first of all, we get the difference. The difference is 130 minus 126. All right. We get 4 kgs. All right. Now, 4 kgs multiplied by the standard cost per unit or per kg of $2. We are getting a variance of $8. That's the variance. But is this variance adverse or favorable? You need to ask yourself that question, and you discover that this was okay, given that the actual quantities used were 130 versus the budgeted quantities. The actual quantity is a standard mix of 126. You can see that this was adverse. Okay, that's an adverse variance. Sure, my A is visible, isn't it? Let me write it nicely, but I thought it's a little bit visible. Okay, that's $8 adverse. Now, this time around, we're gonna be quick. All right. So if we come to the $80, right? The 80. If you come to the 8 kgs there, for material B, if we come to material B, the actual quantities were 8 kgs, but now the actual quantity is at standard mix based on the ratio. Remember, we were saying we needed 40 kgs for material B and 60 kgs of material A. So 40 over the total inputs of 100, okay, multiplied by 210. We are going to get how much? Let me use this calculator. Okay, so we are going to get 84. kgs. Okay. Where is my calculator on the screen there? Because I must use that one. Okay. Now, we are now having B, all right, and for the computation of the difference, we need to say 80 kgs minus 84 kgs, and we should get 4 kgs difference. And that difference is then multiplied by the standard cost. From the question, the standard cost is 3 kgs for material B. I mean, $3 per kg. So $3 multiplied by 4 kgs, which was the difference between 80 and 84. We are going to get 4 multiplied by 3, that's $12. But now, shall we put the $12 here? No. Here we say that this is the standard cost of $3 per unit according to the question there. So the $12 is written in the variance column, $12. But is this $12 favorable or adverse? We come back to the bracket, okay? The bracket is actually the AQ minus AQS. So 80 was the actual, 80 kgs were the actual materials used, but the budget was saying 84. So we used less than the budget. And this time around, this is a favorable variance. 80, which was the actual quantity, is less than the actual quantities at standard mix. All right, the standard mix was saying that we should have used 84 kgs. However, we used the actual quantities were 80 kgs. So that's favorable. Then we multiply the difference by the standard cost per kg of $3 and we get $12 favorable. So what is the total variance? The total, but remember this is the total row. Okay, so the total there should be 8 adverse is a negative, then 12 favorable is a positive. So we are getting an ultimate variance of $4, which is favorable. Is that clear, ladies and gentlemen? I hope you have been assisted there. So let's do the next part. Okay, now we are looking at the materials yield variance, and we agreed that this is the actual quantities, the standard mix minus the standard quantities. Okay, the standard quantity, right? And we said that we have shortened it to simply SQ because it's standard quantity at standard mix. All right. So so far it doesn't make sense, like I said, but you see why I said you need to tell yourself that it's standard quantity at standard mix. Why? Because we've got more than one components of materials. We've got component A, component B, or material type A, material type B, right? So there should be the mix ideology at the back of your mind. Okay, then multiplied by the standard cost per unit of raw materials. In this case, the unitary measure is kgs. So it's cost per kg. Now we come up with the table as usual. We've got materials. Okay, materials. We've got AQSM. We've got SQ. All right, SQ. And I said it's an SM again. Then we've got the standard cost per unit. No need to put a large column there. And then we've got the variance. So we've got material A, material B, all right? And the actual quantities, if you're lucky that in the examination you are required to calculate both the material mix and the yield variances in the same question. Obviously, what you have obtained as the actual quantities at standard mix should actually be the same here. Okay, so what were the actual quantities in our previous computations, right? Let me try to locate them. Let me try to locate those ones. Okay, guys, the information we need here. All right, so I think we have got 126 for material A and 84 for material B. All right, you will see as we do this on Excel that it's not going to be tedious. All right, so let's come back to our current edit. All right, so we are looking at 126 kgs and 84 kgs. We have done this. So in an examination, you would have done that computation and you need not to, worry about them anymore. You just have to copy and paste on your solution. You copy and paste. Then for the standard quantity now, this is why I said now, if it was a single, product or a single material to be used, we're not going to be worried easily. You're not going to be worried. You simply pick the standard. Usually in that situation, it will be given for you. But now, in this case, the standard is not given. All right. So you need to compute that. Right. And for you to do that, you need to do some little bit of workings. All right. So we want to know the inputs, the standard inputs versus output. Input versus output. So the information given by our generous examiner is that, okay, there's a core. Okay. All right. Like I said, all right, you need to then know the standard mix, all right? But for you to know that, you need to know the input and output, all right? So the input information for 100 kgs was that you input 100 kgs and the output was 100 units, all right? But now you are told that the output was 210 units. Sorry, the output is not 210. Okay, we are sorry for that. I'm sorry for that. I like this pen, right? I think, right, let us use that one. Okay, the output, information for the output, ladies and gentlemen, is given in our question. Is very, very clear. The output was 200 units. Sorry, I'm sorry for that. So the output was 200 units. So if we were using our ratio 1:1, obviously we should be looking at 200 kgs of input, isn't it? We should be looking at 200 kgs of input. But for the benefit of us, okay, and others who would face a different scenario in the examination where the ratio is not exactly 1-to-1, because in reality, normally there are aspects to do with normal losses and so forth. So it is not really going to be 1-to-1, or sometimes owing to certain, yield aspects. For example, sometimes you might input 100 kgs, but the ultimate product would be maybe 500 products. So the ratios are not normally going to be 1-to-1 all the time. So what is important is to understand how you are going to maneuver the terrain. We know that to produce 100 units, you need 100 kgs of raw materials, all right? What about when we want to produce 200 units? So if we produce 200 units, the ratio of inputs, or the quantities of inputs, should be found by 200. All right, let me just write here. All right, so the SQ, standard quantities of inputs, should be, all right? Remember, this is the total, right? So the standard quantities, all right, of inputs. Remember, these, the 210 there has been wrongly placed, right? 210 is not necessary there, right? It should be 200, but we want to determine how to compute the 200. So let me just remove that, right? For now, it should not be there, all right? Good. Now, our SQ, the SQ, as I've said, is that should be given by 200, 100 units over 100 units multiplied by 100 kgs. Why? Because we are saying 100 kgs are required to produce 100 units. But the information we have is that we produce 200 units. So to get the kgs required, we're going to say 200 units, which is the current production, divided by the budgeted production of 100 units, multiplied by the 100 kgs of inputs. Right? Remember, 1 kgs of inputs for 200. So this time around, the zeros cross each other, and 2 multiplied by 100 kgs, we come to 200 kgs. This is the 200 kgs we need here. That's the standard quantity. But what about the mix? So this is now, I said, you need to tell yourself that this SQ column should be standard quantities at standard mix. You might know the standard quantities there. All right, the 200 here is the standard quantity in total, but you need then to tell the examiner the standard quantities in standard mix. All right, so give us the mix now, or the mix ratio of these items, the 200 kgs of raw materials. In what proportion should they be? All right, in what proportion? And we have been given the original proportion, where we were told that we need 60 kgs. Remember, the proportion for the 100 items was for the 100 kgs was 60 and 40. Okay, 60 and 40, but it was 60 over 100 of kgs, 40 over 100 kgs. Then you multiply by the figure of how much of 200 kgs now. So this is the standard quantity, right? And we should get 0.6 multiplied by 200. This is 60 over 100, that's 0.6, isn't it? So 0.6 multiplied by 200, and this should give us 120. That's simple arithmetic, isn't it? Then 0.4 multiplied by 200, this gives us 80. Okay, with that in mind, you then have to slot in these figures that have been given to you, where we're told that the cost per kg for material A was $2, for material B $3. So you have to slot in those figures as quickly as possible, right? And that's 2, and here that's 3. Okay, and then you do your cross multiplication, I mean the multiplication, all right? But you need then to tell yourself which figures am I first. I mean, you need to obtain the difference first before you do n computation. So the difference is between 126 and 120 there. All right, that's 6. 126 minus 120, that's 6 multiplied by 2, that's $12. All right, and then you come to B, that's 84 minus 80, that's 4 kgs multiplied by $3, that's 12. Okay, good. And then you need to add up. But before you add up, you need to tell yourself, is this with these variances adverse or favorable? Let us look at the first one. The actual quantity at standard mix was 126, but the standard quantity at standard mix was that one. So which one is your actual and which one is your budget? All right, so the actual here is this column and this is the budget column, right? So actually we used 126 kgs, right? 126 kgs versus 120. Was this adverse or favorable? This was adverse. Then we come to the second one. Actually, we used 84 versus 80. So this one again is adverse. So if we add up, we come to 24 adverse. Once we have done this, ladies and gentlemen, we do not stop there. All right? We do not stop there. We then calculate what is called the material usage variance. Okay, it was not required in this, at this particular example, but for the purpose of teaching, I think it is necessary for us. So for starters, we know that MUV is equal to the material mix plus the material yield variances, isn't it? The mix and yield variances, right? So in this case, remember the mix variance was showing a $4 favorable. If you still remember, you can replay that part of the video. The mix was $4 favorable, and the yield is now showing $24 adverse. Okay, $24 adverse. So this gives us an ultimate MU, or the total MUV of 20 adverse. $20 what? Adverse. All right. But we can then do the MUV variance separately to see if what we have been doing so far is actually in line with, or is actually correct, or was correct. Because if you do not do that, then there is going to be some challenges. All right, so we need to compute the material usage variance separately. Let us compute it separately, regardless of the fact that, well, it is the sum of the material mix variance and material yield variance. So let us do the computation separately to see if we can as well come to the same conclusions. All right, so let me try to add a page there. All right, so we know that material usage variance is equal to actual quantities, right? Minus standard quantity multiplied by the standard cost. Now, we know that, but we should then come to the table. Okay, we want the materials column, then the AQ, actual quantities column, and the standard quantities column, standard cost, and the variance column. So A, B, those are the materials we have been working with so far. All right, so the actual quantities used, we have got the information, that's 130 kgs, 80 kgs. All right, now the standard quantity is not given. This is why I say the standard quantity there is actually the standard quantity in standard mix or at standard mix. You're not given, right? So you need to lead yourself. Haven't we done this computation for the SQ so far? You just have to follow the same principles which we have used, all right? And we've done the computations when we were doing the, the yield variance. Okay, you can replay the video to that part, or I can then show you here. Okay, so as you can see here, this is how we calculated the material. As you can see, these were the figures. These are the figures we needed. That was our standard quantity. And for material A, we obtained 120, and for material B, we obtained 80. All right? The standard quantities in total were 200 kgs. So replay that part of the video. So in an examination, sometimes if the examiner started by asking you to compute the material usage variance, okay, just know that the standard quantities column should actually follow that. If they did not give you those quantities, they should follow that mix. And these were the original ratios which I incorporated there. And how did you get this 200? The 200 we are using, we found it from the workings part, right? Where we say that if we know that the standard was 100 kgs for 100 units, then obviously to get 200 units, to produce 200 units of output, we need 200 units of output divided by the 100 units of output multiplied by the 100 kgs of inputs. All right, and we obtained the 200 kgs of inputs, and these are the kgs we then utilized in the computation. Okay, these were the 200 kgs of inputs, which we called the standard quantities. I hope this part of the video has been very, very useful. So let's proceed with our computation. So the figures we need from this part are the 120 and 80. Okay, 120 kgs is standard quantities for A and 8 kgs for B. Right, so we need to go back to the part of the video we should continue with, right? So sorry, there could be some mix-up as I proceed, right? Good, I found it rightly well. Now, so we said we need 120 and 80, right? 120 kgs there and 80. I was just trying to show you how you should obtain those, the figures for that column. It's not an issue of guessing. All right. Once we have done that, okay, once we have done that, we come to the standard cost, and the standard cost per unit for material A is 2, for B is 3. $2, $3. So for your variance for A, you need to get the difference between 130 and 120. That's 10 multiplied by $2. That's $20. Is this variance adverse or favorable? If the actual quantities were 130 against the budget of 120, so obviously this one should be adverse. Then for B, we actually used, okay, let's first get the total. All right, so we are saying 80 minus 80, the difference is 0 multiplied by 3, that's a 0. So the total there should be 20, which is adverse. Okay, and this is similar to what we have on the screen there, right? On the left screen, we are also having the $20 adverse, and this has been found from adding the material mix variance and or to the materials yield variance. Okay, I think you guys have been helped this far, right, with this computation. I think I've done some little bit of justice to ensure that everybody has been covered very, very well. Now, there is an example from the Kaplan stud kit, which we need to go through together, where we calculated the materials yield variance. And I feel that if we use the table way of doing things, you guys are also going to benefit. All right, so let us do that example together, and then we call it quits. Then I expect to meet you in the long question, which I'm going to use to attack these variances as well as the sales variances and the there's another material variance we did not talk about, the material price variance. We are going to deal with that one again. Then as also we are going to touch on the planning and operational variances. Then we call it quits, isn't it? Good. So let's move straight to the example from the Kaplan start kit. Start kit. Okay, ladies and gentlemen, that's the question we need to solve. Sorry. Okay, guys. Sorry. Sometimes when I'll be looking at the pen, this machine starts to misbehave. All right. We have got that question. Okay, it's an example adapted from the Kaplan start date. All right. We give credit to them. Okay. Question 100. Hondru operates a standard costing system. The standard direct materials to produce 1,000 units of output is as follows. Material grade, right? So this time, these are the grades of the materials which are involved. We have got grade A, B, C, and then input quantity, okay, or the inputs or the raw materials. They are in kgs, right? And the quantities are 600 to 40, 360. All right. And as you can see, the examiner is not giving you, is not going to give you. Right? If you're lucky, he gives you. And this time around, he did not give you the totals. You need to lead yourself to say, okay, fine. So in terms of tonnage or in terms of the weight, what is the total kgs? What were the total kgs? So this time if you add, you can see that that's 0, 4 plus 6, that's a 10, carry 1, 7, 9, 12. So we are looking at 1,200 kgs. 1,200 kgs. And what is that? This is the standard quantity. We are talking of the standard materials budget, standard direct materials budget. So those are the standard quantities. And what is the standard mix? The standard mix is 600 as to 40 as to 3 schist. So what is the ratio per each grade of material? All right. So to get the ratio, you then have to say, let's say for A, you just have to say 600. So let me just list them here. For A, we are looking at 600 over 1,200. This is the 1,200 we are talking about. We have calculated that 1,200 and we get the percentage required, isn't it? Let me use my separate calculator this side. So we are looking at 600. It's very essential, that information. Don't say, oh, you're now starting something new again. No, we are still doing the same, but this time around, I've seen that without these, we are going to start computations over and over again. Okay, but if you are doing all these on Excel, it's not going to be much task because Excel will be doing the computations in the background, isn't it? So for A, the ratio should be 0.5 of the total. Then B, we are looking at 240 over 1,200, and the ratio should be 0.035. 0.035. 0.035. And then lastly, grade C, we are looking at 360. 360. Okay. I'm sure you guys are with me. All right. I've been fixing the screen and everything is now there. Okay. And I still have the image which I took some time ago. All right. And the question, as you can see on the screen, is very elaborate and clear. Now, we need to read further the question to understand what's going on. So during April, the actual output of the product was 21,000 units. The actual materials used to produce the output given there is as listed. So we've got the material grade, the material grade and the quantities which were actually used. All right. And that information is very, very essential. We need to add again to come to the total. So 14,000 plus 5,500 plus 5,500 again, that's 11 plus 14, that's 25. So 25,000. So these were the inputs in total, the actual inputs which were used in the production. All right. But the standard which we were given was for the 1,000 units, for 1,000 units. So the budget was based on 1,000 units, but the actual production we are given now was 21,000 from 25,000 kgs. Okay, so you need to be able to use this information properly because you might end up confusing yourselves. So, what is then the standard quantity for the actual quantities which were done there? For the actual units which were produced. What is this one? This information here, the first information, this whole information, let me, what can I say there? Okay, this whole information, all right, is talking of the actual quantities in standard mix. All right. In actual mix. It's talking of actual quantities in actual mix. So it's actually talking of the AQ, which was used or which is essential in the computation of the material mix variance. But now, in the material yield variance, we want the actual quantity at standard mix. So we've got a lot of work to do this time around. After we do that computation, we also have to do the computation for the standard quantity in standard mix. So you've got two separate columns which need to be attended to. But the best part of it, or the fortunate part, is that we have already computed the ratios. This is why I took my screen, right? This is why it's very important to have that. So let me just re-put the total. We are the 25,000, which we have calculated as the total inputs there. It's very essential to have that information. All right, we can as well, before we go to our table, we can as well determine the standard quantities. All right, we have got the actual quantities which we have presented on the screen there, but we need the standard quantities. So how do we arrive at those quantities? All right, so the inputs, we do our input versus output table. Remember that, isn't it? So the input versus output. All right, now for the input, we were told that to produce 1,000 units, we would need about 1,200. Okay, we were told of that, isn't it? The 1,200, if you still remember. So we need 1,200 for how many units? For 1,000 units. All right. Now, what is the SQ? The standard quantity. Remember that. For how much? For 21,000 units. What is the standard quantity of inputs for 21,000 units? Because we were told that the actual production was 21,000 units as shown here. So to do that, we now know to do that, to get the standard quantity in total, that's 21,000 over the 1,000 benchmark or the standard, multiplied by the standard inputs of 1,200 kgs. And if we cross out the zeros, we are left with 21 multiplied by 1,200. And if we use the calculator, we are going to say 21 multiplied by 1,200 kgs, and we can see that the standard quantity is 25,200. So the SQ is equal to 25,200 kgs. In the exam, there won't be much time, so this is why we are just doing the computation of the screen there. Sometimes I've seen comments saying that your screen is not tidy, there is a lot of clutter, this and that. We will be trying to ensure that you gather as much information as possible on the same screen, isn't it? Okay, now we have all the basic information we need, so let us create our table. We'll start with the materials, material grade. Okay, because if you simply say material, some examiners will be irritated. Okay, actual quantities at standard mix, standard quantities, standard cost per unit, variance. Okay, with this information, we have got material grade A, B, C, and the actual quantity at standard mix. We have got those ratios, ladies and gentlemen, which we calculated. Remember, okay? So what I still remember was that A was 0.5. That was the ratio, isn't it? We calculated these ratios. How do we get 0.5? Just for you to remember. We said, let's say for A, we said 600 over 1,200. The 1,200 is the total of 600 plus 240 plus 360. We get 1,200. Okay, and this 600 over 1,200 is equal to 0.5. So that's why we put the 0.5 there. Okay, and the other one was 0.2. And the rest is obviously because they should add up to 1 or to 100%. That's this other one is 0.3. Okay, with that, what are we trying to do here? We know that the actual quantities used, the actual quantities of materials were we added them. This is the information for the actual quantities. They were a total of 25,000. So you just slot in your 25,000 here just to check yourself. Otherwise, you'll be confused, isn't it? Okay. And then you then redistribute or allocate. Okay. You allocate the 25,000 among the material grades. So 0.5 multiplied by 25,000. And this one multiplied by 25,000. This one multiplied by 25,000. Okay, and these guys should give you, okay, so for example, for A, let's put the figure for A. For A, we are saying equal sign there. 0.5 multiplied by 25,000, that's mathematically 12,500. You can verify with your calculator. Okay, for those of you who are doubting Thomas's, I can't see my, my calculator. Where did you go? It has already vanished and can't see it even here. So if I say calculator, I must be able to open it fast. Okay, guys, the calculator is back. Okay, so let me just pin it to the taskbar. Yes, so that it won't go away. Now, that's 0.5, let's say 0.5 multiplied by 25,000. That's a half of 25,000, which is 12,500. Then for B, we do the same, 0.2 multiplied by 25,000. It's like 2 multiplied by 25. That's 5,000, isn't it? Okay. You should be comfortable with these simple mathematical processes, right? Just close the calculator there, no need. Then 0.3 multiplied by 25,000, that's multiplied by 5 by 25, that's 75. So this is 7,500, yes. Good. So we are good to go. We have done the computations relating to the actual quantities in standard mix. Let's do the same computations for the same computation for the standard quantities. Now, we have computed the standard quantity in total, and this was 25,200. As you can see there, 25,200. Okay, so 25,200 has to be distributed, allocated to the standard quantity following the standard mix of 0.5, 0.2 for B, and 0.3 for C. Isn't it easier, ladies and gentlemen? It's very, very easy. Okay, so we multiply here by 25,200 kgs, 25,200 by 25,200. Okay, so what do we get for the first one? For the first one, it's very interesting, isn't it? Okay, for the first one, 0.2, this one now, it's got a lot of digits, so you can't just do it by the head, unless you're a mathematical genius. So 0.5 multiplied by 25,200, that's 12,600. So this one is 12,600. Then for B, we are saying 0.2. Sorry, I'm typing on the wrong screen. 0.2 applied by 25,200. That's 5,040. And then for this other part, we are talking of 0.3 multiplied by 25,200. That's 7,560. Okay, and then we know the standard price per kilo. This has been given as 1.1 for A, 240 for B, 150 for C. So let us just copy and paste 1.1. And remember, these are in dollars. Okay, 1.1, 240, 150. Right? So all you need to do now is to get the difference first and multiply the difference by the standard cost per kg. So this time around, we start with 12,500 kgs minus 12,600 kgs. The difference is 100 kgs. Okay? 100 kgs multiplied by the price per kg of $10. That's a total of $110. I mean, a product of $110, and that's the variance. But is it favorable or adverse? You ask yourself. Okay, the actual quantity is a standard mix, becomes your actual budget, your actual result. So this one is the budgeted performance, and this one is the I'm sorry for that. This is actually the actual budget. Oh, sorry for that. And sorry guys. I know you were already in the mood. We're rolling now. We're rolling, and this type of erasers, if you're not careful, you end up erasing everything. Okay, let me try to rewrite everything there for you guys. We are talking of standard mix here, and this one was the standard quantity. So I was saying, guys, okay, I was saying, please don't be paranoid. Okay, I was saying this becomes the actual, whereas this one becomes the budget. Okay, it has been flexed, but we can, for the purpose of comparing or determining the right variance here of, we are simply saying the flexed actual, okay, the flexed performance, which was we flexed the actual. So the actual here was 25,500 units being used against the budget of 12,600. So you can see that here this was favorable. Okay, why favorable? Because we are saying we used the materials which were lower, the material quantities which were lesser than the budgeted ones. Okay, so we used less material than expected. So there was some material saving. So this is why we are giving a favorable variance there, right? So in terms of efficiency, we were efficient because we saved. What about in terms of material grade B? In terms of material grade B, we used 5,000 when we were expected to use 5,040. So once again, here we should have a favorable variance. Now, the variance is given from the difference between 5,000 and 5,040. That's 40 multiplied by $2.40, and we should get 96. And this is again favorable. Then lastly, for C, we used 7,500 against 7,560. The difference is 60, and this is favorable. Why? Because we used less. So 60 multiplied by $50, this gives us 90. Favorable, okay? So the total variance should be 110 plus 96 plus 90, and this leads us to 296. Favorable. Okay, and let me tidy up the screen to see if we have obtained the right thing. So a favorable materials yield variance usually speaks of the efficiency. We have been efficient in saving up these material inputs, right? The standard quantity in producing 21,000 units was supposed to be 25,200 kgs. However, we used 25,000 kgs. So we can say we were in the right direction. Let us see what the Kaplan authors said about this result. So allow me, ladies and gentlemen, to share what the guys did, right? So you can see that the guys did not use the tabular format for the yield variance here, okay? But they still came to the same variance of 297. Remember here, the difference was due to the rounding of the the proportions. Those proportions, when we calculated the 0.5, 0.2, there were certain decimal places which were ignored, or we rounded upwards, which means the rounding affected us. We found 296, but these guys have got 297, which means we were actually in the right direction. Then in terms of the comment, their comment was that the favorable variance is due to more output being achieved than was expected from the materials input. Now, should you use the table or the like presenting the information in a simplified way, and then maybe try to like do a weighted approach, something like that? This is actually up to you, but you need to then be able to follow what you have been doing. All right, according to my computations, according to my view, I think a tabular format is well worthful, should be given all the due appreciation or consideration, as it has got the potential of awarding you more marks. The examiners would not find it very difficult to follow your processes or your computations, and that would give you a lot of advantage. Okay, but as well, for the benefit of learning, you can as well follow this format. I've shown it in my computation, a similar way of doing. Oh God, I've cut the, the slide by mistake there. All right, and so for that, okay. Sorry, I'm sorry guys. Okay. Question hunt. Okay. I was saying that this is the computation which I tried to do as well, and you can as well relate this solution with what the Kaplan guys did, and you can as well see that according to my computations, we are still at 296. This is theirs, which was 297, and all these roundings affect the results. Those decimals and so forth. But that's not a big deal. You will always pass your question if you do the processes properly. Okay, and as you can see again on the screen there, let me show you the the computations. All right, so as you can see, the screen. Okay, you can easily follow, all right, the processes adopted if you have yes, I don't know what this thing is doing. It's okay. Hope you're seeing properly. All right, you can as well see how we have been doing it. All right, what we've been doing was very clear to markers, right? They won't find a hard time to mark your solution because tables usually are organized and easier to follow. That being said, ladies and gentlemen, I think we can safely say that we are ready to do the long exam question together. Everyone is now comfortable with the material mix and yield variances. All right, so meet me, ladies and gentlemen, in the next video. Thank you. I am signing out.